Okay, 9.1 is called sequences. So I'm going to talk about the PowerPoint and then I'm going to go through the examples. The sequence is defined by as a function whose domain is a set of positive integers. Although a sequence is a function, it is commonly represented by a subscript notation. So a is a 1 is a first term, a is a 2 is a second term, and so on. So listen the terms of a sequence. Literally, you're going to plug in number 1, you're going to plug in the 2, you're going to plug in the 3, you're going to plug in the 4. Okay? So, a sequence whose terms are approaching a limiting value is said to converge. Okay? So, if it goes on forever and ever, and then that will be divergent. Okay? So here it says, let L be real numbers. The limit of the sequence is L, written in this format. If for every epsilon greater than 0, there's an m greater than 0 such that a of n minus the limit, it's less than epsilon. So here what it's saying is we're just looking for the limit. Okay, I'll show you right now how we're going to find that. Here are some examples. We're also going to talk about factorial, and let me just say what is factorial. It is just that exclamation symbol, but what that means, n factorial, is I write it backwards. I like starting with n and then going from n, let's say n is 5. So then we're going to go 5 times 4 times 3 times 2 times 1. So from that number, and you go all the way to 1. Again, we'll do that right now. Okay, so I went and created the assignment, and then I'm going to go over questions right from your assignment. Okay, so this first one is just us to simplify the ratio of factorials. Okay, so what does that mean? Okay, so again, I start with what I'm given, and then I go back. What does that mean? What does n plus 1 mean? That means you have n, and that's the next one. So then what goes before that? You're subtracting 1 every time. So it'll be n minus 1. The next one, I'm subtracting 1 again, so then it'll be n minus 2. And then that way I can keep on going until I get to 1. But since I do not know what n is, I can just finish it here and finish with the factorial because it keeps on going forever that way. This one's right here. Again, you start with the whatever you're given, and we're subtracting 1. But n minus 1 minus 1 will n minus 2. And then it goes n minus 3, and so on and so forth. But look at that. Okay. Well, this one's the same as this one. Just as this one's the same as this one. Even if we have factorials, they're still the same. Okay. So what do I have left? I have n plus 1 times n. So we can distribute, and it will be n squared plus n. And that will be the simplification for this particular question. Okay, limits now. Limits. Find the limits. Okay, this is what the question is going to look like. Find the limits. This is what we're going to be doing. Okay, we're going to find the limit as n approaches infinity. And we have 5n plus 4 over 5n. Okay, I care about infinity. So when we go to infinity, it doesn't really matter that I have plus 4. Because I'm going to have a huge number. It's like a really, really big number plus 4 is still a really, really, really big number. So I'm going to ignore the 4. And I'm only looking at the highest exponents of n. In this case, it's n and n. They're the same exponent. If you have the same exponent, you're going to put them over each other. And we're going to simplify. The n's cancel. And then 5 over 5 will be 1. So then the limit as n approaches infinity of a of n will be in this case a 1. Okay. I'm going to do another one. I know I'm going to do another one because you're like, what? Okay, I'm going to do another one. It says find the limit of the sequence. Okay, so again, you have 4n. We're going to find the limit as n approaches infinity of 4n square root of n squared plus 1. Okay. Well, what do I do in this case? Again, I care about the highest exponent. In the top, I only have for n, so I'm going to have for n. In the denominator, I have a plus 1. But as I'm going to infinity, I don't care if I have a plus 1 or not. I'm going to ignore it. So I'm going to have the square root of n squared. Well, the square root of n, the squared and the square root cancel. So I'm going to have 4n over n. Well, what's the coefficient in front of the n when there's no number? Well, we have a 1. The n's cancel. So we have 4 over 1. So my limit is going to be a 4. Okay, so limit is going to be 4. Well, what happens in a different scenario? Okay, I'm going to show you what happens if the n's don't cancel. Okay, so for the previous one and this one, n's cancel. What happens if they don't? Okay, it says determine the convergence or divergence of the sequence with the given nth term. If the sequence converges, find the limit. Okay, well, how do I know it converges or it doesn't? Well, if it goes to infinity, like this one, the denominator is going to go really, really grow. It's going to grow, grow, and grow. So if you put a number over a really, really big number, it's going to really get close to 0. So in this case, when you have n in the denominator as your highest exponent, and you put a really big number, it's going to approach 0. So in this case, this one right here is going to be a convergent sequence, convergent, as it goes to the nth term. And the limit as n goes to infinity for this right here, again, if I put a really, 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 really big number in the denominator, it's going to approach 0. So in this case, my limit is 0. Okay, so it will be 0 when you have in the denominator a higher exponent than in the numerator. Okay, for example, so here I'm just going to do a little break. You have n squared, and in the n squared plus n plus 1, and then I have n cubed plus 2. I don't care about this. I don't care about those. I only care about the highest exponent and simplifying them. Because when I simplify this, it would end up as 1 over n. And 1 over n converges, or if you put infinity, the limit will be 0. Okay? So that one's that one. In this case, remember we said about, if again, we have n, and we're subtracting this. Okay. Well, in this case, I have infinity here. Remember, we're talking about to see if the limit as n approaches infinity, if there's a limit. So in this case, sorry, this is a of n, not just separate, but is a of n. So as this goes to infinity, I'm putting infinity there. Minus a number. Even this right here, even if this goes to to 0, because it's 1 over n. Remember, n over 1 over n, the limit will go to 0. The limit as n approaches infinity of 1 over n is 0. This is 0, but this one's n. If you have n, in this case, my limit will be infinity. There's no limit. So in this case, this is going to be a divergent sequence. Divergent. So when you plug in n, the limit doesn't exist. It's still infinity. Okay? So the limit as n approaches infinity and you have n or n to a power 2, power 3, doesn't really matter. That's going to be infinity. It doesn't simplify nicely like this one. Okay? And that is 9.1.